working as an assistant professor in Department of Mechanical, Walchand Institute of Technology, Solapur. Today, we will be discussing on the topic project management and the forecasting errors. Learning outcome. At the end of these sessions, students will be able to investigate what is the forecasting errors. What is the matter covered will be introduction. What are the forecasting errors which are being used if used during the project management? We generally forecast it for our new project. So what will be the forecasting errors? How it has been calculated? Typically in manufacturing type of industry. Which are the errors? It is mean absolute deviation, which is also called as MAD. The second is bias. The third is mean absolute percentage error, which is called MAPE, MAPE. The next one is fourth one, mean squared error, which is called MSE, and finally the tracking signal. First, we will understand what do we mean by forecasting errors. The forecasting error is a difference between the actual value and forecast value for corresponding period. The error can be represented as error in the period T is equal to YT minus FT, where E is forecast error at the period T, Y is actual value at the period T, and F is forecasted for the period T. Forecasting error can be calendar forecast error or cross-sectional forecast error when we want to summarize the forecasting error over a group of units. If we observe the average forecast error for the time series of forecast, the same period, product or phenomenon, then we call this calendar forecast error or time series forecast error. If we observe this for multiple products for same period, then it is called cross-sectional performance error. Generally, these both type of errors are there when we are going for the new project, because we start initially with some forecast with one product. Over a period of time, if the product is big, then that becomes a big thing. Mean absolute deviation, which is also called as MAD, indicates on an average basis how many units the forecast is off from the actual data. MAD can be represented as summation of ET divided by N, where ET is absolute value of error, N is number of periods of evaluation. The second forecasting error is bias. It indicates directional tendency of forecast errors, which side it is moving. If the forecast repeatedly overestimate actual demand, bias will have positive value, and underestimation will indicate the negative value. So bias positive means forecasted is overestimated. Bias negative means forecast is underestimated. And the same mathematical model we can put it as bias is equal to sum of forecast error for all periods divided by number of periods, which is equal to forecast demand minus actual demand divided by N. So we can see if the forecast demand is more than the actual demand, the bias becomes positive, and if forecast demand is less than actual demand, then bias is negative. So this indicates our planning phase or during the phase whether we are more cautious or we are more casual in our approach. Bias should be almost near to zero. Mean absolute percentage error. Now this is absolute value comes, so absolute itself indicates there will be no direction, no negative or positive. It indicates on an average basis how much percentage the forecast is off from the actual data. MAD can be represented, MAT, if represented as summation of ET upon AT into 100, absolute value of error, number of periods of evaluation, and actual demand of period T. Mean squared error or forecast error measures the penalizes a large error proportionally more than small errors. MSC. summation of ET square divided by n, where ET is value of error, number of periods of evaluation. Tracking signal, the ratio of cumulative forecast error to corresponding value of MAD. It monitors any forecast that has been made in the comparison with actual and warns when there is unexpected departure of outcomes from the forecast. The tracking signal can be summation of bracket actual value minus forecast divided by MAD, mean absolute deviation. Let us understand this calculation or with the small example given. The data given is sales and what was the forecast. What was the actual forecast when we let us say a project is there and we launch the thing and that it was happened that it will be doing good in our coming months. Then we try to find out what we forecasted and what was the actual figures for that sales or for that product, for that company. Period from 1 to 10, sales is 1600, forecast was 1650. Period 2. Period can be in months, period can be in quarters, period can be in years, it depends upon project. The third is 2000 is the sales actual value rather than forecast of 2200. Fourth is 1600, it comes to be 1580. Then comes fifth 2500, the value forecast was 2480. Sixth is 3500, 3520 was the forecast. Seventh is 3300 was the actual data, 3310 was the forecasting. In eighth period, the sales was 3200, actual value. 3200 itself also was the forecasting. Ninth was 3900 was actual, 3850 was forecasting. 10th was 4700 and forecast was 4720. Now we please calculate what are the errors, bias, MAD, MAPE and MSC. Now these are the calculation. First we found out error, what is been there, the error sales minus forecast. Error comes out to be 50. We have calculated for each period minus 50, 190, minus 200, 20, 20, minus 20, minus 10, 0, which was the best period I will say for the 8th period. 9th is 50, 10th is minus 20, and we have found out what is the addition of the value is comes out to be minus 20. Summation of E, which has been used in our diff with help of formulas what we have spoken just few minutes back. Then we have found out mod of that, means we have removed the direction and the value comes out to be, means only that's positive or negative is being removed, so the value comes out. And then again we have found out the summation which comes out to be 580. With plus minus direction it comes to be minus 20, with summation E comes to be 580. E square we have calculated, which is required. 50 square 2500, 190 square 36100, 200 square 40,000, 20 square 400, 20 square 400. So we have calculated, and yes, summation of E square has been done and it comes out to be 82,800. Now mod of E divided by A comes out to be, divided by A means actual. Sales means mod of E is 50, 50 divided by 1600. Please calculate. It comes out to be 0.0313. Same way for sales 2, mod of it has been calculated as 190 divided by 2200. The third 200 divided by 2000. 20 divided by 1600. 20 divided by 2500. 20 divided by 3500. 10 divided by 3300. 0 divided by 3200. So we are taking 0. It comes out to be 0. 2500 means 50 divided by 3900 comes out to be 128, and then finally 20 divided by 4700, which comes out to be 0.0043. So we have calculated the bias, and bias comes out to be, as the bias is having directional value, it comes out to be minus 20 divided by 10, which is minus 2. Mean absolute deviation, which is mean summation of E divided by 10 periods we have taken. So 580 divided by 10, which comes out to be 58. So bias and MSE we have already calculated it. MSE mean, so it has been calculated on the basis of mean squared error, which has been calculated on the basis of E square. Error square name itself suggests mean squared error. So square of error, which has come to be 82,800. Period again is 10, so 8280, and the MAPE mean absolute percentage error, and percentage error comes out to be 2.64. Now please think, what if bias is positive or 0? I've already told you in my previous slide if bias comes out to be positive or negative. Please think. So the references used for this slide are the notes or the courses from NPTEL, a great initiative by IITs and IIMs, and then the book from Ronald and Adam of Production and Operation Management, 5th edition, and tracking signals definition we have taken from Wikipedia. Thank you.